Ladies and gentlemen, please welcome Principal Software Engineer, Pivotal, Stephane Maldini.
Good morning. I hope you have a fine event with us. And today, I'm on stage to do a quick checkup on a reactive story. Surprise. So, as a quick retrospective, for the first time we talked about a reactive story, it was in SpringOne, at SpringOne Las Vegas in 2016, yeah. And the reason we did that comes down to an actual question we asked ourselves as software developers. What do we want to do with our software? And my answer to that will be, I want my code to compile, then I can ship it. But more seriously, I want actually to write new features quicker than my competition. I want to innovate faster. But also, because I run or I work for a successful business, I want to make sure that the application I write is scaling properly with the user traffic. So we did answer some of these questions. And we try to help writing more efficiently microservices with a small project you haven't heard about, Spring Boot. And then we also try to work on how to help you write non-blocking application, because we know non-blocking application actually help at scaling with user traffic. So we created this project called Project Reactor. And at the time, we released the version 3, which was a combined effort with the Spring team and the RX Java team to create this foundation for reactive stream on Java 8 and beyond. So with this foundation, the next big thing we had to do, well, we have Spring, so we need to create a project on top of that. We created the Spring Web Flux as a reminder of the one of the two types we have in Reactor, Flux. That was our first reactive story in Spring. And the next thing, obviously, we shipped it on one of the best places on the internet. I will say the best one, but one of the best, start.spring.io. And the next thing, obviously, we took Josh, we cloned him, and we sent him all over the world to talk about the reactive revolution, sometimes at the same time in different places. That's how far we went with our concurrency story. So the thing we did then for the next 2 years was to work on our whole stack, because I will ask you a question. What Spring is not? It is not a single project, obviously. And we have a whole set of things we cover. We want to help every day-to-day problems on every day-to-day problems a software developer has, like data access, security, or cloud integration, integration patterns, everything. So we created and worked on a reactive story for all of these projects. And that was great. We helped with this small project, again, called Spring Boot. We helped making reactive a bit more popular. We started humbly with 100,000 downloads a month for Reactor to now north of 5 million, so 8 or 9 nowadays. And that's where we are. Nowadays, we know we have a certain recognition from the industry with our reactive story. And we just released Reactor 3.3 and Spring Framework 5.2, and you will have Spring Boot 2.2 in your hands pretty soon, famous last words. But we noticed the industry adoption is accelerating. We've seen our project mentioned in tech radars, and that's great, you know. We've seen this recognition here. We've seen our project adopted into different vendors like driver for databases or SDK for cloud access like Azure SDK. And that's great because they're pretty happy about the use case they have here, and they're pretty happy about using Reactor. They, I quote, use a high-quality async API. And they also use the latest tooling we provide to our Reactor and reactive users in general, which is Blockhound, and you'll probably see and discover more on that later and today. So what else can we do then to push the extra step for the extra mile for the recognition? Well, making sure that these reactive practices are enshrined, are somewhere neutral, everyone can refer to and learn about. We discussed with a bunch of companies around strong reactive advocates, and we decided to create a reactive foundation. So we did announce that a few weeks ago, And the aim of the foundation is really to help promoting reactive practices, but also host a few specifications, including reactive streams, to make sure that we have a continuity in supporting this project for a long time. So what are we doing next? The next thing, actually, this is a slide from 2016 when we announced for the first time the Spring Reactive Story. We showed you already that we could create a reactive application with reactive programming. So inside the same application, we connect components in a reactive way. And we did that for the next 2 years. That's what I just said. And the thing is, reactive streams is more than non-blocking programming. It is, in my opinion, a protocol. So it has a set of qualities, a contract we have to implement as a producer of data or as a consumer of data. And these qualities actually are important to make your application more resilient, more scalable. But what do we do with a protocol, actually? Usually, we don't constrain a protocol to an application. We go beyond an application. We do a network protocol. And that's exactly what is RSocket. That's very much the very core of RSocket is to port these qualities over the network. So reactive qualities apply across network boundaries. And for this year, we are proud to announce that we have a set of projects already implementing RSocket as a first-class support for it. So namely Spring Framework, Spring Boot, Spring Integration, very important Spring Security, and one project you will hear more and more, and in the next session, actually, from Spencer, Spring Cloud Gateway. So now we can connect applications the reactive way. That's great. What else can we do? Well, we can address a very interesting problem. Most of our users use Spring with a relational data access, and that's important for them, and we won't change that immediately for sure, and we don't need to change it anyway. So last year, we announced the work we were doing on R2DBC, or Reactive Relational Database Access API. So this year, we are very happy to announce that we have R2DBC in a Spring Data portfolio, Spring Data R2DBC, but also we have support for it with the transaction support at transactional, the very canonical annotation a lot of Spring users already know. But also we worked as a community, because this is very much a community effort. We worked with a few companies around and a few contributors for various places to work on drivers implementation, like Microsoft SQL Driver or Google Spanner or SAP HANA, and Postgres as well, and MySQL. So it's very much a thing now, and I encourage everyone to give a try, because now we can actually connect also a relational database the reactive way. And the last thing we worked on was really the reactive experience, because we keep having feedback. I visit customers time to time, and I'm asking them, what do you want us to do to make sure that you have a positive reactive experience? So we worked on that, and we created a set of tools, including block count, a project that helps you diagnose if your application is using blocking code inside a non-blocking stuff, something you shouldn't do, actually, Reactor debug, and we also improve our observability story with more metrics from Nedi and even Reactor core itself. Importantly as well, we want to meet our users where they are, and if they are Kotlin developers, we want to make sure we provide them with the right support. So Spring Framework 5.2 introduced strong coroutine support with coroutine and flow as a first-class support. And they use the same stack we also use when you just use Reactor, for instance. They use the reactive stack we've created. So very interesting that we provide that. And we continue working. Latest example of the things we're doing, we have a service discovery for Kubernetes API the reactive way, because you might do that in your reactive pipeline. We worked on reactive object pooling, and more, and I think the story is not going to end here. The thing is, I want to show you the experience live a bit, at least, and I need to probably stop talking. And to do the demo now, I'm going to invite Violeta, the heroic contributor to both Tomcat and Nedi, and she's going to guide you through this demo while I'm going to type behind my laptop. Thank you.
Hi, SpringOne.
Hello,
Hi,
Lisa.
Stephane. Shall we start with a demo?
Yeah, I want to create a reactive application.
Let's start then. The demo today is a mini conference site, and it contains 2 microservices and a front end. The first microservice is speakers service, and it provides information for the speakers. The second one provides information for the sessions, and the front end obtains that information and provides it to the end user. Let's look at the session service. What we have in the POM XML. The session service is Spring Boot application, and it uses Spring Web MVC. It uses JDBC for accessing the database, and also we use Postgre as a database. Let's see our sessions repository. The sessions repository is a standard CRUD repository, and in addition to the functionality that the CRUD repository provides, we have here possibility to search sessions for a particular day. And let's see our controller, what we have there. In the controller, we have two endpoints. The first one returns all the sessions, and the second one returns sessions for a particular day. Shall we try that?
Yep, I already started that.
As we use Spring Web MVC, we see here Tomcat is started. And in the browser, we can see our sessions.
Nice. Oh, that's all the reactive session. Cool. That's where you should go.
OK, but you know, I expect very high loads to our application. So how we will scale that?
Should we do reactive now? Can I do reactive?
Yeah, let's switch the application to use Spring Web Flux.
OK. Let me take a shortcut. Whoop. And ta-da!
And now what we changed actually is the starter. Instead of using the starter for Spring Web MVC, we use the starter for Web Flux. And we are OK.
Yeah, well, yeah. I just want to restart my application. And you say everything is fine. OK.
OK, and as we are using Spring Web Flux, now we should be able to see that Net is running instead of Tomcat.
Oh, yeah, it's Netty now. But it's cool, you work on both projects anyway, so. All right, refreshing. Yeah, still working.
Still working, yes.
So.
Are we good?
Yeah, are we good, actually? Nothing changed. Yeah,
actually, no? I remember that we use the standard driver for Postgre. Isn't it blocking one?
No, we can't use blocking code inside a non-blocking path. And Reactor Native is very much non-blocking.
How we can check whether our application has blocking calls?
Using blockcount?
Yeah, okay. Let's do that.
So teleporting into the future.
So what we need is just a dependency in our POM XML to blockhound.
It is here.
Yeah, and in addition to that, we need to initialize the blockhound in our main method in the application.
I see it here.
So let's test our application.
Restarting. There we go. I can spam my refresh button. Oh, what happened? What?
500? Why?
I don't know. It says 500 from list session. OK. So I guess, oh, yes, this service failed. What happened? Could not open JDBC connection because...
Oh, no, it's really a blocking driver.
We need to solve that problem. I can't stand that. No. What do we do?
Let's switch to R2DBC.
OK. Teleporting again into the future.
Let's start again with our famous POM XML. So what we have here now, instead of the standard JDBC, we have R2DBC, and also we use the non-blocking interactive driver for Postgre.
Nice.
Let's see what we have in the sessions repository. The sessions repository now is a reactive CRUD repository, and our additional functionality returns now flux of sessions instead of list of sessions.
Nice.
And what we have in the controller, again, our both endpoints return flux of sessions.
But it's pretty much the same. I mean, apart from the return type, it does look the same convention. That's
and it's not blocking.
And are you sure? So it's not going to fail if I refresh? Oh my God, it's working.
Our application is live again. Oh.
Pretty much, yeah. All right. What else? What's the next thing we can do now? It's all non-blocking.
OK, we are reactive in our application. But what I want is actually to be reactive between the applications. Can we transfer the back pressure between the applications?
Yep, I think we can. That's exactly what this little protocol named RSocket is about. Let's try to use it, because I've heard Spring support it now. Teleporting into the future again. Oh.
Let's check the POM XML again. And there, we have a starter for RSocket.
Nice. I like starters. Easy.
Let's look at our controller. And in our controller, now the endpoint, we do not have get mapping, but we have message mapping. But all the rest is one and the same.
That feels like pretty consistent with what we had before, actually.
Yeah.
So if I start, you tell me it's still going to work, but not with HTTP, now with RSocket?
Yeah.
Okay.
And while we are waiting, let's look at the application properties file.
Okay.
Here, we specified that we will use WebSocket transport, but we can use also TCP as a transport.
That's cool. Wow, it's still working.
Yes. And do you want to show you what we have in the front-end controller?
We have a very much a bit of time. Front and application controller. All right.
Typically, we use web client for remote calls, but now with RSocket, we can use the RSocket requester. And what we need for the RSocket requester is just the remote system. We need to specify the transport. And later, we need to specify the route that we need in order to obtain the information.
Right. So like this.
Yes.
That's pretty cool. But then everything is the same. So that's awesome. Yeah, cool. How do I know everything was working as intended? Do we have some kind of metrics?
Yeah, let's see the metrics.
They were running in the background.
With our new metrics, we can see information for the requests, the response time, the data that was transferred through the network. But in addition to that, we also can see the connection pool state and also the connect time. And one thing that you will like a lot, we can monitor the direct memory used by Netty.
Nice. That's exactly the memory that the JVM doesn't want to report. So you think it's not using memory, but it's actually using memory. I like that.
In addition to these metrics, we also have TLS handshake monitoring, DNS resolution monitoring, etc.
I think that's pretty cool. I hope it's going to encourage you to try this stuff. We really invested into, I know you have invested into Spring for a long time, and we try to keep a maximum of this learning you have acquired and port it over the reactive stuff. So you're not lost when you try the reactive stack. You recognize, the same conventions. That's really the takeaway we want for you to have. And I hope, I hope we see you in the next sessions, which I'm going to leave you with. Thank you so much.